I'd like to introduce you this evening to our two speakers. I will also make a comment too that at the end of the program, after the questions and answers, they do actually have the reconstructions here, which they will be wheeling out and letting you see up close and personal, and you can actually come to the front of the auditorium and speak with both of the lecturers in person and look at the artwork. So first I'd like to introduce you to Brian Baade, who will be the first speaker this evening. Brian Baade originally trained as a fine art painter, and he received a Bachelor's of Fine Arts from the Art Institute of Chicago. His interest in technical art history led him to transition into art conservation. He went on to receive a Master's of Science with a certificate in art conservation from the Winter University of Delaware program in art conservation. Brian has completed numerous technical studies and reconstructions of historic paintings. And one of his more recent studies has been a collaborative project between the Pennsylvania Academy of Fine Arts and the American Art Museum, working with both myself and a scientist, Jennifer Jakai, at the Museum Conservation Institute in writing a chapter that will be included in the exhibition catalog for Henry Ossawa Tanner. That'll be coming out actually in the next year. So you can actually learn more about that up in our Luce and Lender centers. Brian is currently an independent researcher, paintings conservator in private practice, and an instructor and researcher of painting materials and techniques and painting conservation at the University of Delaware. The second speaker this evening will be Kristin deGhetaldi. Kristin is a paintings conservator who graduated in 2008 with a Master's of Science degree from the Winter University of Delaware program in conservation. You see a common theme here. She's currently completing a 3-year Andrew W. Mellon Fellowship in Paintings Conservation at the National Gallery of Art, working on the treatment of old master easel paintings. Under the guidance of scientists and conservators at the NGA, Kristin has been given the opportunity to use a variety of analytical techniques focusing on the questions specifically relating to media analysis. She has also participated in internships and conservation positions at the J. Paul Getty Museum, the Rijksmuseum in Amsterdam, and the RISD Museum. Kristin earned a post-baccalaureate certificate in conservation in 2008 at the Studio Art Centers Internationale in Florence, Italy, and a BA in 2003 in chemistry from Grinnell College. Please join me in welcoming both of our speakers this evening.
So thanks, Amber, and thank you all for braving the rain. I understand it started to rain out there, so I'm glad you made it. So reenacting the masters, historically accurate reconstructions of paintings from the Kress collection. First of all, what is a reconstruction? I'm sure when you read that out on the flyer out there, you said, well, it's intriguing, but I have no idea what that means. So what is a reconstruction versus a copy of a painting? A reconstruction is a copy of a painting, but it's a copy of a painting that's done as closely as possible using exactly the same materials by the original artist, the exact same layering structure, and everything that can be done to do that is close to the way that the original artist did to create that. A copy is what we think of as a copy is really just an attempt to emulate the surface qualities of a work. It really doesn't have anything to do with how the artist worked. This is more moving into technical art history or even art history rather than simply the fine arts. Why is a reconstruction valuable? You might wonder that as well. I mean, we could just go at look at the original artwork, right? Well, that would be true if reconstructions were simply an attempt to replicate surface effects. But a reconstruction, because it is about layering, we can use that to help educate students in graduate and undergraduate programs. I have specifically spoken with students and given classes with students working on these reconstructions so that they can understand the complexity of old master paintings or even of all fine art. Museum education departments can use these reconstructions in a way that you could never use an original piece of artwork. You can bring these out and bring that out into the gallery and have students stand around it, even, oh no, touch it. All sorts of things that you would never do with an original piece of artwork. The general public art historians can learn from these, and you'll see in a moment why that's even better than the original artwork as far as for the education of how these things were put together. And finally, web-based education. These can, because I document all of the layers in the reconstruction, this documentation, both photographic and written, could then go on the web and could then educate many people that would never be able to make it to that specific museum. So this particular project, as it says in the title, Paintings from the Kress collection. Samuel H. Kress was an entrepreneur who made his fortune on the Kress 5 and dime, and then he started to collect early Italian paintings in the 1920s. He started a foundation because he was very interested in educating the public about art. And between the 40s and 1961, he dispersed 3,100 pieces of old masterwork to museums around the United States. 400 of those went to the National Gallery in the 40s. So there need to be some criteria for the selection of what would make a good reconstruction. So some of those criteria are, we need to have a lot of technical and analytical data about the original artwork or about the artist in particular so that we're not making things up when we're reconstructing this. We really want this to be based on scientific knowledge of exactly what went into that artwork. We need cross-sections, perhaps X-radiographs, infrared reflectograms, and I'll show you what those are in a moment. We need comprehensive art historical information. I would really like to have a lot of documentation of the time period, maybe manuals or handbooks that were put out during the time that the artwork was made, so that we have the things that we can't learn from the analytical tools, we might have from the documentation of the day. And obviously, the chosen artworks should be represented in the host museum, the museum that's going to host these reconstructions. It makes a lot of sense for, at least for them to have an artwork by the same artist, but it's probably for the best as if it's this reconstruction from that museum, a painting from that museum. So further criteria, the imagery should be 1-to-1 scale with the original. And the reason for that is if you do a blow-up of a Van Gogh, the quality of that paint that you apply with a brush is very different than if it were the original size, or even if it were smaller. We're really trying to figure out how that artist worked, and the only way to really come up with any clues from that is to do it 1-to-1 scale, and once again, with all of the materials that they used whenever possible. And that leads into number 2. They should be exactly historically accurate materials. If it calls for hand-ground lapis lazuli that goes for $400 a pound, well, that's what we need to do. Otherwise, using a modern synthesized version of ultramarine will not create anything that resembles what was done in the day. And finally, which is what I was leading up to before, is these are going to be done cross-sectionally. Layering is going to be revealed so that you can, after the reconstruction is complete, still see all of those steps that it took to create the reconstruction. And that's what aids us in our education. So you see here an image from the MFA in Boston where reconstructions that I did early on were done for something called the Artist Toolbox, where they would go out into the galleries and show these reconstructions in front of works. So we have a reconstruction of a Monet here with some examples of Monet behind it, allowing the docents and volunteers to really go through and talk about the materiality of artwork. It is wonderful. It is a wonderful document of the history and aesthetics, but it's also a material object that took layering and artist hands to actually create. And you see here a group of very esteemed scholars at the National Gallery looking over one of the reconstructions that I'll be speaking about in just a moment. This is the Giotto reconstruction. So the Giotto painting here and the Giotto reconstruction. You're immediately struck by how they resemble each other, but my goodness, that's blue and that's green. Well, I'll talk about that in a moment. So, as I just said, Giotto. Giotto is really the father of Florentine Italian Renaissance art. He's really the father of humanist art, art that's representing the human as an important being, that they're important in and of themselves and they look like people. So this is when we start to see people that actually resemble people. The Madonna, while we may think she's a little archaic today, was a giant leap forward in realism. So Giotto is Florentine, as I said. He's the 13th to the early 14th century. This Madonna and Child is one of a number of panels that went together. This particular Madonna and Child is called the Goldman Madonna because Goldman owned it for a period of time. And this was donated to the National Gallery from the Samuel H. Kress collection in 1939 when they donated many, in fact, about 400 pieces of artwork. I mentioned before we need to have substantial documentation. These are a number of publications that relate to the Giotto. A really great small publication by one of the conservators at the National Gallery, Elizabeth Walmsley, who wrote about the panel. There are just a number of other really good technical books out there that talk about early Italian painting. We have the Craftsman's Handbook, which is an artist's handbook from the 15th century, 1400s, about 100 years later, talking about Florentine art practice. So we have that to go to and to learn about what we're going to use to make this reconstruction. So first of all, early Italian paintings. They're painted on wooden panels. They're not on canvas. That doesn't actually start to occur on a regular basis until 1500. This is painted on a very large piece of wood, as you can see here. It would have originally been painted on European poplar. And if you can imagine how big of a tree you need to make a piece of wood that big, unfortunately, European poplar no longer grows that large. It's been deforested in Europe, and it's not available in the United States. So this is one of those times where you have to deviate from your stated goal is everything as accurate as possible. Well, I had to take a piece of wood that was similar to that and use that because otherwise I couldn't have actually done a panel this large. A panel of wood, though, is not a good substrate really to paint an egg tempera painting on, which is what this is. The wood is uneven, it's not of a uniform color, it's not uniform in porosity. We need to lock that layer down, create a more uniform porosity. And so what was done at the time was to take animal skin, in this instance parchment scraps, boil that up, boil that collagen glue out of those parchment scraps, and then use that to seal that wooden surface. This is going to be something that's going to come up quite a few times in the next hour. One of the ways that people dealt with the fact that wood, when it ages, it cracks, right? We see very old pieces of furniture that have cracks in them. Well, we don't want that crack to transfer through the ground and paint layers. We'd like to stop that if possible. Well, one of the mechanisms that was used at the time to stop that was to use a fabric overlay between the panel and the ground. Hopefully, if that panel starts to crack, that canvas will then serve as a buffer and not have that crack transmute through the canvas. You see a number of people helping me here. I taught a class at the University of Delaware specifically related to 3 reconstructions for the Kress Foundation, and a few of these individuals will pop up again later. So you see that panel with the fabric overlay. That would have been sized again with the animal glue to cut the absorption of the canvas. But still, even the canvas isn't a good surface to paint on. To do an egg tempera painting, we really want like an eggshell, smooth, beautiful surface to paint on. So we need to apply some kind of ground to that. What was done in early Italian paintings was to take calcium sulfate or gypsum, and what you would do is you would create plaster of Paris. What we call plaster of Paris today is really calcium sulfate gypsum, which is heated. It drives off of its waters of hydration. I won't go into chemistry too much, I swear. Drive off the waters of hydration, and then it's so water hungry that when you put it in contact with water, it solidifies into a hard surface. So that's why we can use it on walls. Well, a very similar thing was done in early Italian panels. We need to have a really thick white ground, not only to make a nice surface for that egg tempera paint, but we're also going to put a lot of gold leaf on here. And to make gold leaf really shine, we need to have kind of a cushion of ground that we can then burnish. So we're going to put on a really thick layer of what's called gesso grosso, or just coarse gesso. This is that plaster of Paris mixed with the same animal glue, and that's really just spatula it over the surface. You can put a lot on all at once. Sandpaper is not real common in the 1300s in Florence. In fact, it doesn't become common until the 19th century. One of the ways that you could make a panel smooth after you've applied it with that spatula and you know it's a very uneven surface is to take charcoal, rub it over the surface, and then take a flat metal scraper and just keep scraping. Once there's no charcoal left on that surface, you know it's smooth. It may not be perfectly planar, but it's smooth. That gesso grosso is wonderful for putting it on a nice thick layer, but it's not very good for making a beautiful eggshell like ivory smooth surface. So we need to apply a thinner ground on top of that to actually give us something to paint on. So what we do with that is we take that same plaster of Paris, we put that in a large amount of water and we stir it, and actually we stir this for a month. What that does is it actually precipitates out a hydrated calcium sulfate that's finer and whiter than anything that we started with. This is an early, wonderful chemical reaction that created a product that we would today have to do through synthesis. You take that gesso sottile, or fine gesso, add it to our old friend animal skin glue, and apply that. And go through the same process of smoothing it. And here's that panel. It's ready for painting. Or is it? Wait, we might have to do some other things first. We need to put down the outlines of the image. I need to know what's going to be gilded and what's going to be painted. This is an infrared reflectogram. What infrared reflectograms are essentially infrared light can penetrate through paint layers in a way that visible light cannot. So if there's a carbon-based, carbon like charcoal or black chalk, underdrawing, we can see it using an infrared camera. So we can see in this that there are, well, I can see up close, that there are two types of underdrawing here. There is an outline that creates the entire periphery of the image, and then there's some finer shading. We know it's some carbon black-based underdrawing material because, first of all, we wouldn't see it if it wasn't. We also know it was probably done with a quill or a brush because it appears to be fluid and therefore liquid. How do we get that drawing on there, though? I mean, it's kind of scary to just take your ink and then start drawing on that panel. Well, that was handled in two ways at this time. One was just to draw it in charcoal until you liked it, and then you went over that again with your ink and kind of made those lines permanent. The second way of doing it, and the way that I'm actually showing you here, and there's no way to know on this particular object which way was done, is to make a cartoon, which is a full-size drawing. You then puncture all of your outlines with fine little holes. We put that over top of our panel, and then we dust the surface with charcoal. The charcoal goes through those holes and then leaves a dot on the panel. It's a kind of an early form of photocopying. We could do this time and time and time again. And one of the reasons this was done, not only to bring the drawing to the panel, but if you had a workshop and needed to do 10 of these, you really don't need to have the assistant draw 10 times out there. You could do the master could do one nice cartoon, and then they could be transferred to all the panels. So you see here where those dots, also called spalvero, those little dots of charcoal have gone through. I'll then go and then reinforce all those with ink. The ink at this time really would have been one of two different things. One is almost exactly the same as if you go to the store and get lamp black watercolor. It's a gum Arabic-based ink with lamp black pigment. And that's what was used here. So you see that reinforced underdrawing there. But we're going to gold leaf this, which means we're going to apply gold on it. It's going to overlap over our line, so we're going to lose our outline. Well, the way they handled that at the time was to take a stylus and inscribe along all of the outside peripheral lines, so that if we gold leaf over it and then we go over the line, we'll still see that indentation of the stylus. I had mentioned before that there were two types of underdrawing. Well, this is another type of infrared camera, a much more powerful infrared camera, which shows that not only do we have these outlines, but we also have evidence of a more fully shaded underdrawing here. And that was done to create kind of the basis for the paint on top. You kind of can work out a lot of the value structure in your underdrawing and then deal more with color once you get to painting. The technique at the time, and pay no attention to the gold on there, the technique at the time was to use a large brush, put your finger in it to spread the bristles out to make a fan-like brush, because there were no fan brushes until the Industrial Revolution. There was no way to make that metal furl. And to use that and to dry brush your ink on there so that you could create a kind of a dry brush or a wash-like technique. So we're going to move into gold leaf. We haven't even got to painting yet. The gold leaf is, that gesso grosso, gesso sottile are really good surface for creating a gilded surface, but they're not perfect. We want something that's really, really soft and smushy, something we can really burnish, that create that gold that looks like it's a solid sheet of gold. So what was done was they'd take red clay, natural red clay, which is a aluminum particle that they're like plates. So when you apply them, they're all sitting all over the place, but then if you burnish them, they lay down flat and make just a mirror smooth surface. That's going to be our optimal surface for applying gold leaf. So you see here that bowl being applied wherever it's going to be, the gold leaf is going to be applied, a number of steps, and then that was burnished. Often it was burnished or even smoothed and polished using a horsehair cloth, something that has a little bit of abrasiveness to it, but not so much that it's going to cut through the bowl. So we moved to gilding. Gilding sheets of gold leaf originally were made by taking the Italian coin, the ducat, putting them between pieces of really, really, really fine parchment or skin and beating that. And we know how ductile and malleable gold is, so you can make a huge, you beat that until it's this big, you cut that into fours, you put those on top of each other and beat it again until you've got an incredibly fine, thin piece of gold. We can make them much more thin today, though. The gold at that time you could still pick up and lay in place. The gold we have today, that if you out there sneezed, the gold leaf in my hand up here would blow out of my hand. So this is to illustrate that at the time, you could actually take gold leaf, just put it on a wooden paddle, turn it upside down, it would fall in place. Today we have a slightly more complicated procedure. You see a didactic panel here of the bowl. This already has animal skin glue in the grounds and in the bowl, so our adhesive is already there. We have our piece of gold leaf. We're cutting that piece. We're going to apply some water, mostly water with a little alcohol, maybe a tiny bit of glue to that surface. What that'll do is it'll reactivate that gold in the bowl so that when we bring the gold over top of that wet area, electromagnetic forces are going to pull that piece of gold to the surface. And then over the next few minutes, that water will be drawn into the bowl, which will draw that piece of gold flat. So you see here, when it's first applied, doesn't look quite, quite straight, not on there beautifully. Over time, though, it flattens out. And then if we take a really, really hard material, at the time they used dog's teeth. It's a perfect round, kind of curved shape, very hard. And then we burnish that gold, we can really create that mirror-like surface. And you see here, this is the burnished side, and this is the unburnished side of the gold. So for a number of hours, there's enough water left in that bowl and in that ground that we can actually punch designs into the ground without cutting through the gold, but we can create a really, really kind of detailed surface that has a lot of texture that can really reflect the light. Remember, these were in churches, which were lit by candlelight. So anything we do that kind of break up that surface is really going to be beautiful and scintillating in a church at the time. And in fact, the lighting in here, when we look at the reconstruction later, you'll see just what I mean. So here I am punching various designs, these dots in here. If you just use a metal stylus that's not very sharp, you can actually just freehand designs into this, and this is actually in the paint surface. And while this image is pretty illustrative, it's much more interesting. You'll be able to see the actual reconstruction in a little bit. So we will now finally move into the paint. So egg tempera paint. What is egg tempera paint? You see here an illustration from a manuscript from the early 1400s showing a studio where traditional egg tempera paintings were being produced. We have a lackey over here. He's making our paint, which is really just to grind your pigment with water. That's stored in mussel shells. I mean, remember, we don't have ceramic, watercolor palettes or things like that for this. We have, at the time, where it's very common to store them in mussel shells. You have soft hair brushes, much like a red sable that we may use today. We have an easel with the tempera painting, and then a small palette. Interesting, though, that it is a female painter. We know very, very, very few female painters from the 15th century. So that paint is made up of two components. We have a binder, and we have pigment. And pigment is that coloring particle, what's going to impart color to the surface. It needs to be something that's not soluble in the media that you're applying it in. So one of the most common are the iron oxide earth colors, the red and yellow earths that come out of the ground, and they're colored by the iron oxide component. A very important pigment for early Italian are the green earth pigments, and you'll see why in a moment. These are iron-containing silicates, a lot more complicated, but have a greenish tone. Probably the most important pigment in all of easel painting was lead white. Lead made by coiling it over vinegar, putting that in a storage, like a shed, filling that with manure. So what happens is that vinegar acts on the lead, turns lead into lead acetate. The manure gets hot, speeds up that reaction, but also gives off carbon dioxide. That carbon dioxide will then transform that lead acetate into lead carbonate, and that is what's lead white. And lead white has been used since the Roman times at the very latest. It was used for thousands of years and is still used by some oil painters today, despite its toxicity. Natural ultramarine, I had mentioned before, lapis lazuli. The natural ultramarine was the most expensive pigment ever. In fact, it was far, far, far more expensive than gold. It was only available from one place, a very, very remote place in Afghanistan, which is still pretty remote today. You would get the pigment, get the stone, that would be broken up, and they would have to go through a very complex alchemical process to create this purified ultramarine. We have recipes from it. At the time, it went for an enormous amount of money, to the point where often a village would buy a certain supply of ultramarine, they would store it in the keep, and then artists would be doled out small amounts of it, depend on their contract. Very, very important. Vermillion is a red mercury sulfide, another poisonous pigment. This will be something that I talk about a number of times here. Many of the art materials at this time are very, very poisonous. So vermilion was made by mixing mercury and sulfur and putting it over a fire. The two would combine and create this beautiful red pigment. Lead tin yellow, another lead-containing pigment that we find in old masterworks. Very common lamp black, bone black, those carbon-based blacks that I said we can see in infrared reflectograms. But we also have something more interesting. There are a lot of great oranges, like kind of all right yellows that are available from natural earths. We have the blue from ultramarine. But there are a lot of colors we'd like to see in paintings, like purples and brilliant crimsons, that don't really come from rocks. We can't grind up a rock and get a beautiful purple. What was done at the time, this is really ingenious, is they would take dyes that they would use for clothing, where you could get this beautiful natural dye, and then they would stick it onto a substrate, which would then take it from being a dye, which is water soluble, into being something that's not soluble, or a pigment. So they took advantage of a very simple chemical process. If you mix alum and potassium carbonate together, they precipitate out a colorless, it seems like it has color, but it's basically a colorless particle. But if you do that in the presence of a red dye, it'll hold that dye in there. So one of the dyes that I'm going to talk about, or the one I'm going to talk about, is Lac Lake. Shellac yields a beautiful red crimson dye. In fact, for most of the time that shellac has been used, it was used for the dye. It's really not until the 18th century that we could distill alcohol at a high enough level to really dissolve shellac and make it a surface coating. So we have this raw shellac, mixed it with water. Well, that ground it up, mixed it with water, that didn't really create a color. Just add a little bit of an alkali there, we can immediately see that brilliant crimson that came out. I'll filter out all those bug parts, because this is bug excrement. This is bug goo. Filter those bug parts out, mix that alum in to create that reaction, dropping that colorless particle, but it's not colorless anymore. Now it's red. We filter out all of this red dye that didn't react, and then we have that red pigment. So this is, in the medieval times, you had the ability to create these wonderful natural pigments that that really get filled in the blanks. The problem with most of these is they're not very light fast, and we've replaced them with many better modern substitutes. But at the time, there was really no other option. And indigo, you know of indigo, it's the color of the jeans. Well, indigo was another blue that was used at the time. It's not a great blue, it's not a brilliant blue, but it's a lot cheaper than that $10,000 a pound ultramarine. So you make tempera paint by, as I said before, you take your pigment, you grind it up with some water, and then your binder, sorry, I shot through that, grind up with water to make a water paste. You could store that in a mussel shell, as I said. Our binder is egg yolk. So I think most of you have cooked enough to know how to separate your egg from your yolk from your white. You gather up that egg yolk. You mix that with a certain amount of water, usually about 1 to 1. And then we take that pigment paste that we've made from grinding the pigment with water and add it to the egg yolk, about 1 to 1 again. It's all slightly different depending on the pigment and how coarsely ground the pigment is. So we know from other Giotto paintings and also from cross-sections of Giotto paintings that he would often start the first layers of the blue with that cheaper indigo. We see a cross-section up here. I'll tell you what a cross-section is real quick. We take minute, tiny little samples of the painting. We embed those in a piece of plastic. We turn the plastic on its side and cut it off to reveal the cross-section, and then look at it in a microscope. Well, we can take small enough pieces, but we can, at the same time, we can find out what the layering structure is here. And we do have examples of Giotto using indigo in the lower layers and then ultramarine later on. This is actually one of the overlaps where another layer of paint was applied on top. But we know this was started out with indigo and then finished with ultramarine, and quite a bit of ultramarine. Ultramarine was very expensive, but it was also, like most things today, if it's very expensive, there are a lot of people out there that want it, and they know that that confers a degree of honor or of prestige to a work if it's there. The Italians had a tendency to paint most objects relatively simply, really 3 tones, mid-tone, shadow, and highlight. One of the deviations from that is the way they depicted skin. They would start out with a greenish tone. You can see from the cross-section up here a layer of green earth, followed by more kind of skin colors. The same thing is true over on the Reconstruction. The reason that was done is because they would then paint skin tones over the highlighted areas and just let a hint of that green show through in the shadows. It really helped create a very rounded form, but something that kind of had an inner light versus painting a brown for the shadow. The red tones that are applied on top were often called carnations. 3 to 4 mixtures of white in that color, or the reddish color, the skin color, were then applied over top of that green, allowing some of the green to show through, especially in the shadows. So we're almost done with this reconstruction. We've got our gold leaf in our background, it's all tooled, the paint's all been applied, but we want to have some really ornate, fine, filigree-like gold work on here. Well, we can't really do that with that water gilding technique that we talked about before. It's a little too coarse for that. There's no way to brush a perfect line of water and then lay a piece of gold on that. So what was done at the time was they'd take a drying oil, like linseed oil, they'd heat it up with a metal salt that would make it dry quicker, in this instance, lead oxide. And I've reconstructed that recipe here. And then you just paint that where you want it. So I've gone in here with chalk and laid out where I want that filigree gold. And you paint that on there, you let it get tacky, and then you put gold over top of that, basically dry but still tacky mordant. When I brush that gold away afterwards, it only adheres where I've applied that mordant. So you can have this incredibly complicated gold leaf work both here and along the mantle. And from there, actually, I'm going to let Kristin take over. Thank you.
Okay, we're going to move a little bit further north, so to Flanders, and a little bit later. This is a completely different technique. We're going to be dealing mostly with oil paints, but I'll get to that in a minute. First, just to give you a little bit of background about Hans Memling, one of the most important Northern Renaissance painters of his day. He was sought after actually internationally. We know that this painting in particular, which is also on display at the National Gallery, was purchased by Bernardo Bembo, the same person who commissioned our one and only Leonardo da Vinci, so the Ginevra da Vinci portrait in the National Gallery. So the reason why we're seeing two images is that it is double-sided. We display it freestanding, and I'll get to that in a minute, but just to fast forward here. Hans Memling was born in the Middle Rhine region, and he moved to Bruges in about 1465. After which he became very popular. This particular diptych was commissioned, well, it's not necessarily a diptych, but this beautiful cupboard with two paintings on either side was commissioned by the St. John Church in Bruges, and this painting, let me just go back 1 second. This is also part of a diptych, and I'll show you the other side in a little bit. But they're very closely related in style. These are all of the references that we used for obtaining our information. I just want to say this was an amazing show. If you were able to see it in 2006, it was the Prayers and Portraits diptych show at the National Gallery. Kathy Metzger was the paints conservator that did an incredible amount of technical work. She co-authored this with John Hand, excuse me, the curator. And this is the diptych. We don't have the other piece, which is on the left. Thank you. The other piece is in Germany. It's in Munich. These were very, very important pieces of art. You could actually open and close them and travel with them. So if you needed to take a break and pray, you could erect them on any surface and open them up. And they were painted on all four sides. So X-radiography. Brian, I don't think he actually went into X-radiography, so this is a very important thing that we do routinely in conservation departments. We X-ray everything. We also look at everything with infrared reflectography. So X-rays, he talked about IR. IR only penetrates just beneath the paint layers that are visible. X-rays penetrate all the way through. It sounds horrible, but it doesn't harm the painting at all. It's probably more harmful for us, although we do it in a protective environment. The X-rays penetrate all the way through the painting, so we're seeing both images at the same time, which is why it's very confusing. If you remember, we had one image of the goblet, St. John the Evangelist's chalice, and then on the left is the Veil of Veronica image. So we're seeing both transposed together. We're also seeing these tiny sort of vertical lines. That's picking up the wood grain. Then there's these little losses here. We see that routinely, but overall, this painting is in excellent, excellent condition. We also are able to get a feel for paint density. Wherever you see white, especially in the sky region up here, that's where lead white has been used. Lead white is extremely opaque when subjected to X-rays because it is a metal-based pigment. Just like when you go to the dentist, you can see your metal fillings show up very, very well because the metal in that area, the X-rays can't penetrate through them as readily. So we see the same thing with pigments, specifically lead white, but also with vermilion as well because mercury is present in vermilion. In Italy, poplar was often used as a support, but in the north, oak was generally used. It's much more resilient to rot and woodworm damage, and it was also just more common it was just more commonly found. So we take our oak panel, we plane it, as you see one of the students up here doing, plane it smooth. It's very similar next step as with the Giotto. We boil up some of that animal skin glue, extract that collagen. We use that to size the panel. And then, this is an important deviation, we don't use gesso, we don't use gypsum. What they had at hand was calcium carbonate, so chalk. Deposits up north were far more common than gypsum. And how do we know it's chalk? Well, we're able to get these fantastic images with, like this one you see in the bottom left. That's obtained with a scanning electron microscope at extremely high magnification. And these, not only can we assess or tell the difference between chalk and gypsum with other analytical tools, but the evidence that these little structures here, they're called coccoliths. I think I got that right. Those are from actual particles of algae or life form, microorganisms, and what they do is they form sort of a shield using calcium carbonate sheets around them, and of course they die. This is a sample obtained from deposits that were found near Dover, and they leave the structures behind. So these organisms are probably from as early as the Cretaceous period. So we see these pop up every once in a while when we analyze the ground of northern paintings. You go ahead and mix that calcium carbonate with your animal skin glue. You apply that as your ground layer. And there you have it. So remember, we have to deal with two sides of the panel. You scrape down the ground layer just as with the Giotto, so applying charcoal, rubbing it across the surface, then taking a blade and scraping it down. One thing that Brian didn't mention, they didn't have sandpaper, but every once in a while they would sometimes use shark skin. That was about as close as they could get to using sandpaper, but in this case probably a blade was used. So then you see both panels, the ground is ready to go, it's scraped and smooth. And one thing that is amazing about Northern Renaissance artists is their love of drawing. We get some incredible underdrawing images when we're able to use infrared reflectography, and I'll show you the IR image in a minute, but these are two great examples. I especially love this one on the right here, the unfinished Van Eyck. It's just beautiful, exquisite underdrawing, and often these sketches are far more detailed than what we see at the end, the resulting image. So they took a lot of time and effort, and they would use things like metal point occasionally, but often it was charcoal, graphite, or black chalk, as in the case with the Memling. Just to say a few words about this painting, it's got a very interesting conservation history, and it looks rather odd. And the reason why is at some point after it was painted, I believe in the 16th or 17th century, someone decided to have the central Madonna and Child figure, as well as St. John the Baptist, scraped away. And then they were going to, I believe, put two figures sort of to update the painting. That happens. We see that occasionally. And so when this painting was restored, it was decided to take those unoriginal layers off. And unfortunately, all we're left with is the underdrawing today. But this is on display at the Met. You can go see it as is. I should say, I forgot to talk about the significance of this painting. This is the IR underdrawing, but we have St. John the Evangelist chalice on the left, and the snake it sort of documents moment in his life when he was about to drink from a poison cup and blessed it, and the poison turned into a snake and crawled out of the goblet. And then on the side, of course, Veil Veronica. Many of you know the story. She went up to Christ as he was carrying the cross, and she gave him a a cloth to wipe his face with, and when he took it away, that image remained. So that's what both of these stories correspond to. But the underdrawing, again, this is an amazing, just almost spastic linear work. The black chalk used here was very freely handled, and we know it's black chalk because these are very thick strokes, and also charcoal is so friable, we wouldn't see it it wouldn't show up as prominently in the infrared. Also, I don't know if you can make it out here, but there's a triangle that the artist used to sort of get the perspective into, to figure out perspective is very, very tricky, and that's something that these artists were always constantly battling. So if they could work it out in the underdrawing, that was great. So he did Memling did an amazing job in the end with that. The underdrawing on the left-hand side is, we actually found during the process of making this, the underdrawing in her drapery does not correspond very well at all to what we see in the visible paint layers. And this happens from time to time. Artists change their mind as they continue to paint these works. Sometimes they stick to the T of the underdrawing, and sometimes they deviate. Even though the form is relatively the same, the detail in the folds do shift. And there's also some other details that we see, a few faint sketches in the background, but not a whole lot. So there you see the underdrawing being put down, again with the black chalk. So we tried to sort of mimic what we saw in the underdrawing here. All right, probably the biggest difference between the Memling and the Giotto is the paint medium. Egg tempera is very, very, very different to work with than if you're working with oil. Egg tempera dries right away. Almost as after you lift the brush, your stroke is completely dry. So you have to layer upon layer upon layer your colors to actually get that deep, rich blue that you remember seeing for the Giotto. For oil paint, you do have to work in layers, but your drying time is that much longer. You can blend things. Actually, that can work to your disadvantage, especially when you're trying to do these oil paintings in an apartment if you have two long-haired cats, which is something that we found out. It tends to stay tacky for a very long time, but they did have ways of dealing with this, even back then. They knew that, especially in the north, they had ways of pre-polymerizing the oil. So you can do that by heating it up, either over a big fire kettle during the winter, so you risk catching fire to your house, or you could put it out in the sun, so sun-thickened linseed oil. They were masters at refining this medium, which was very, very important. If you had impurities in your oil, if you didn't water wash it, when you press all of these flax seeds, so you see actually a Dutch windmill, some of these are still working today, you can go visit them. When you press these flax seeds down and extract all of that oil, you unfortunately get a lot of that mucilage, a lot of the casings of those seeds as well. So you have to basically water wash it and strain it. It's a very complicated process. So if you don't do that well, your oil paint is not going to dry. Walnut oil is another source for drying oils at this time. And why use walnut oil? It's prepared very much the same way. You mush up your seeds, you extract the oil, but one of the benefits of walnut oil is that it yellows less. Linseed oil does tend to yellow a bit over time as it ages, as it cures. Walnut oil, though, does so even less. However, the downside with that is it takes even longer to dry than linseed oil. So even though it yellows less, you do have to wait a little bit longer for it to dry. So they knew this back then. We often find evidence that walnut oil was used for colors that would especially suffer from yellowing, like blues. If you're going to spend a lot of money on your lapis lazuli, you do not want it to go yellow on you. So they would often use different binding media, especially things like walnut oil. The same goes for whites. So even after you have your underdrawing, you kind of want to lock that underdrawing in place, but you also want to cut the absorbency. When you apply your oil colors, that chalk ground is going to suck the oil in almost immediately. And you want a little bit of that absorption, but you don't want it to be so thirsty. So what they would often do is put a very thin pigmented layer of color, essentially, across the whole thing, you could still see your underdrawing. So you don't want to completely obliterate it. So it was only slightly pigmented, not completely opaque. And this layer has been referred to as an imprimatura layer. You might have read about that, but in the North they would often use the word primicell to distinguish that. So imprimatura usually is used as a term for Italian paintings, and primicell for Northern Renaissance paintings. But the color could vary. It could be gray, it could be yellowish, and in this case, we know that it's this sort of peach color almost. Under high magnification, you can see, especially where planes of color meet along the borders of forms, you can see that faint pink color peeking through. Why the artist chose this color, we don't know, but we're just following the reconstruction and going by what we observe and what we see. Brian already went through all these pigments. I'm not going to go through them again, but they're all used on the Memling. I'm just going to go through a couple new ones. Azurite is another option for blue. It's not as expensive as lapis, but it is found in ore deposits typically, such as there was one in Lyon, France at this time that you were able to find this stone. And as with any of these raw materials, you have to grind them down. And unfortunately, with azurite, it suffers from the fact that the finer that you grind it, the more you lose its color, its blue intensity. So you can obtain a range of blues. If you go with a coarser grade, you're going to still have that vibrant blue color, but it's also a giant pain to work with. It's almost like painting with sand. And then if you grind it even finer, it's easier to work with, but you also get a pigment that's lighter in color. If you get a nice quality fine grade azurite, however, you can sort of, I guess, find a mediation point. We found a really nice fine grade azurite that we chose to use for this painting, which is probably what Memling used for his. Verdigris, also green earth was another alternative, which for green color at that time, and you saw Brian already talked about using it for the base tones of the flesh. But verdigris was a little more complicated. You didn't just dig it out of the ground. You took a strip of copper, you suspended it in a sealed jar or vessel over vinegar again, so kind of like making lead carbonate. It's a little bit more simple than that. You wait over time, and it causes the natural corrosion of copper, just like when you go outside and you see sculptures, the corrosion on the sculptures, that's essentially verdigris. You scrape that off, and you get this beautiful, nice pigment. So to make oil paint, you basically, well, first of all, we were talking about toxicity, wear protection. Back then they did not, but we do know artists did still live a long time. Titian lived to be 90, but not all of them lived that long. So we would take, they often use a granite slab or something smooth. They poured a certain amount, allotted amount of dry pigment. Then you're able to just carefully dip that or pour your medium into the center, almost like a well that you make, and then you grind it and grind it and grind it. Brian showed you that image of the studio with the lackey in the background, and that's precisely what you needed if you wanted to run a really successful studio. These artists, like Memling, would have probably had 4 or 5 apprentices working with him doing this task, and I will tell you it's not fun. And there was also, you had to make sure at the end, you have all this color, you didn't want it to dry and cure on you or become adulterated. So what they would also do is, instead of storing them in mussel shells, sometimes what they would do is store them in pig's bladders or leather vesicles. We decided not to go that route and find pig's bladders to store our paint in. This is just showing you these artists tended to work from the back to the front. It's very, very important when you look at these artworks to remember that. Layering, they knew exactly what to do even from the first step on. They knew that, okay, I need to lay down my blue for my drapery first. In addition to the green in the background, we also see the artist starting to, well, us in this case, starting to lay down the colors on the back. And we have clues. We know how this painting was done layer by layer. If you look at this as pentimenti right here, it's kind of an off color. What that is, as oil paint becomes more or as it ages, it becomes more transparent with time. So we're able to see, this is where the artist actually made it change. It's just a decision that he said, okay, I'm actually going to extend the red robe over this green area right here. So we actually did that sort of change in our own reconstruction. But that tells us that the green pasture or the green fields were put down before the red robe. So it's very important to keep in mind. Just again, building up those colors, constantly layering more and more azurite. I talked about how it's really difficult to use this color. It's like painting with sand, and it becomes easier to work with the more color that you put down, the more layers of azurite. Putting in these fine details, the lead white or the lead tin yellow highlights in the leaves. Again, actually giving this three-dimensionality in the back. And highlights start to go in. Also, the faces were generally saved for the last. It was the most important part. I did talk about apprentices. Sometimes the apprentices would be given the job of doing the background, the less important tasks. The faces may be done by the master. The master might do the whole thing, but the faces were always saved for the master, unless you have an apprentice that's really well on their way, like a young Michelangelo, for example. And just to show you the next stage, and here it is finished. And we're not quite done though. We have one more step. All the paint layers are in place, but back then we do know that they varnish their paintings. Varnishes are very, very tricky things to make. They're generally made from resins. So you take tree exudates, basically, or things like amber. You have to heat them up to extremely high temperatures. Very, very dangerous to make. And you can combine that typically with oil. That's what they would do at this time. So they'd make these oil resin varnishes and put them on their paintings. Now what that did is that not only it protected the paint layers, but it imparted saturation. It made the painting pop. The darks went darker, and the lights, it made them pop out more. We chose not to use an oil resin varnish because we are conservators, and we have to deal with sort of removing oil resin varnishes occasionally. They become extremely dark and discolored to the point where you cannot even enjoy the painting anymore. So it's in fact quite rare to find an oil resin varnish, original oil resin varnish applied by these artists intact, because usually by the 1700s they've all been removed. But in this case, we did want to varnish the painting because this artist, that would have been a very important step. So we chose to use mastic, which would have been available at that time, but we didn't add oil to it, which it's not going to yellow and discolor nearly to the degree that an oil resin varnish would. So here's the image, and I don't know if you could probably make it out a little bit here along this line. So this is varnished, this is not. And this is varnished, and this is not. And then we're going to wheel out the paintings after the Q&A, so you'll be able to tell the difference a lot more when you actually see them in the flesh. And I think that's about it. Oh, I just wanted to end. These are all the reconstructions that we have made. A lot of them live at the MFA in Boston. So we've done anywhere from Duccio to Arthur Dove. The El Greco, though, is the one that is also at the National Gallery. So the three at the National Gallery right now are the Memling, the Giotto, and the El Greco. But this project has been very humbling and also a great learning experience for us, as well as the museums that are using them today. They're great didactics, and they've been so much fun to make. So with that, I just want to thank the Samuel H. Kress Foundation, above and beyond the Samuel H. Kress Foundation, the Smithsonian for having us here today, the National Gallery of Art, and all of the amazing people that have helped us through making these things and also consulting us. And I think with that, we'll take some questions. Thank you very much.
So once again, if you have a question, please come up to the mic.
Can you talk about some of the challenges of actually, becoming the artist yourself and having to paint these things, how they did it? I know you got some training in that, but it must still be kind of difficult.
Well, yeah, it's exceptionally difficult. In fact, one of the things that I think you learn when you start to do this, and one of the reasons why I think it's so important to use these original materials, is if I went out there to the store and bought a tube of well, they don't make tubes of azurite, but let's say if I could buy a tube of azurite, it would most likely be a synthesized pigment, which would be incredibly fine, and it would be just like painting with all your other oil paints that you got when you go to Utrecht to buy them. When you're painting with these stones, you realize that it requires a specific technique to even accomplish getting that paint on the surface. You have to apply the paint in a different way. So we fought and swore a lot during the creation of these. I am not a master gilder by any means, and I went through books and books and books of that gold paint with having it go off and having, you know, laying it down. Martin here is a frame conservator here is probably laughing at me. You go through an enormous amount to try to create these, and I do have a background as a painter. I was an exhibiting painter for 12 years before going into conservation. It's still different.
I should also add, I am not trained as a painter at all. I have a chemistry background, so I had a much steeper learning curve, especially when dealing with, I did not work on the Giotto, but I did a lot of work on the Memling. And I will have to say that materials make a ton of difference. And if you're trying to make these reconstructions, if you are doing a copy of a painting, you just can't get as close with, you know, modern synthetic ultramarine or even other colors that you buy off the shelf. I mean, it's really incredible. My skill level was down here, but I learned how to work with the materials, and I was able to do things that I probably couldn't do with modern materials that are available today.
Yeah, let me just put in a plug again. One of the things about these historic materials is that, yeah, they're very difficult to work with, so why would you work with them beyond the education purpose? But there is something to be said about that, a coarse-grained pigment. It kind of refracts light in a different sort of way. It has a different quality than a homogenized, precipitated 21st century off-the-shelf pigment. It has a quality to it that maybe is difficult to achieve, but is unachievable with modern materials. So even just for our personal growth, there's something going through the trials and tribulations of that is wonderful. I teach classes every semester on historic materials, paintings, and historic painting materials and techniques. And that's one of the things we go through in all these classes is that students are just so surprised how difficult it is to even get the materials to work for you. Are there any other questions?
All right.
Well, we've got one coming.
Thank you very much. That was fascinating. About the cartoon, you went by that rather fast, and you implied that it was possible to take the cartoon and to reuse it or to use it in the studio. Do your researches tend to support that? I mean, when you finished with your cartoon, you still had a nice piece of paper with some nice little dots in it that you could reapply?
Oh, absolutely. I mean, all it is it's a little dirty from there on out. It has a little charcoal on the surface, but that doesn't hamper it in any sort of way. Now, we don't have a lot of cartoons that have come down to us, but we do have some. We have some that have been pounced and have come down to us as actual pieces of artwork. But what we also have are infrared reflectograms of a lot of paintings that you can see the same copy at numerous museums and they can fit one-to-one. We can, with computers, go in there and overlay those and see that they don't deviate at all, so we know that a cartoon was used from. We also know from, we know from Vasari and Cennini that cartoons were used for putting the underdrawings up on frescoes. It's a well-known process.
I should also add that just because we find evidence that a cartoon is used to create a painting, sometimes we can actually see the dots in the infrared. But that doesn't always imply that it was used to make a bunch of copies. Right. For example, our Leonardo da Vinci at the gallery was used, was made by applying a cartoon first. And we're able to see all these precious dots around her mouth and nose. And that was probably done because he went to her and he did a sketch of her instead of having her come to him, day after day to a studio. He tried to get it right on the parchment or paper, or whatever he used, and then he brought that back to a studio, pounced it, and that's how he was able to get a perfect likeness without actually having to sit with her for hours and hours.
Well, and then the other possibility there is that I would always want to work out on my preliminary lines on a piece of paper and not on my final panel.
I'm just wondering about the wear process. I mean, is it possible that you would have a cartoon, you'd use it maybe once or twice and then you'd
You wouldn't need to, because all that happens is just the charcoal powder just falls through that hole. You're not really causing any wear and tear.
Thank you.
Raphael, or how one of the pound stories on exhibit periodically?
So the Hammer collection has a Raphael cartoon. There are, you will see in technical sections of books where a drawing that is being exhibited as a drawing does have some pounce holes in it. So it was obviously both a drawing and it was a cartoon at some point.
Yes. I hope you can hear me.
I'll read it, that's
fine. Has this increased your respect for some of the more notorious and successful forgers?
Well, okay, did that increase my respect for notorious or known forgers? I'm really torn on that, because actually if you can pull off a great copy of an old masterwork, I have a certain kind of gut level respect for you. On the other hand, the museum employee in me rails against that. What's really interesting is that even though they're often, at the time when a painting was done, Van Meegeren or someone like that supposedly made a lot of fakes of Vermeer, there are people that believed it at the time, but if we look back at it, we can't believe they believed it because they were actually painted nothing like Vermeer. And so I don't know that I have an answer for that. I respect anyone with a lot of skill, but there are skillful people in jail. Are there any questions? Yeah.
How long did the process take you, and how much did it cost, if you could say?
Well, I should go into how much the grant was for me. I would say that I think I was given about 7 months to do it, and I did it in 10. Each time I do these, they never fit into the schedule of when I wanted to do it. One is dry time. The other is most of these were done in our kitchen. So I haven't been working in a real studio. Starting in August, I'll be teaching full-time again at the University of Delaware, so I'll have a full-time access to a large studio. Things will probably move a lot more smoothly. I'm working on a set of 2 of them for the Kress right now, one for the Portland Museum of Art in Oregon, another for Seattle Art Museum, and those are both running long as well. They tend to take far more time than I would ever imagine. I'm glad I'm not doing this by the hour and I have to come up with a bid.
Yes. Is there a good preference on this that we can read about it?
On reconstructions or on technical aspects of paintings? There are a number of good technical aspects of paintings books. I showed at the very beginning I think I just lost it now. Okay. If we just shoot back to the very beginning, there is a series from the National Gallery in London called Art in the Making, and that's incredible on this. They'll go through everything like I did, and Kristin did, talking about the layering and what materials were there, and they would often also go through the the cross-sections that show them how that was. There are sometimes that there are reconstructions done in there. I know there's a reconstruction of an early Italian panel painting similar to the one I've showed you here.
The National Gallery Technical Bulletin series also, they have about, 32 now?
Yeah.
32 published. Those are excellent. They're a little bit more all over the place, so you might get an edition that has a case study on a Monet and a Tiepolo, but that's great. If you can afford the whole set, you have an enormous amount of technical information on your bookshelf right there.
So this is just one example of art in the making. There are quite a few of them. There's one on Italian painting. There's one on Impressionism. There's one on Degas. There are quite a few that are, and they're just wonderful. They're the first place I would look, and you can probably get them at the National Gallery DC in the bookstore. So anyway, here are the 2 reconstructions that we were speaking about, and you're welcome to come up and take a look. And some of the raw materials that were used to make the reconstructions are there as well. I even have a dog's tooth there.
Yes.
When a painting is crackled,
When a painting is crackled from age, how do you repeat that in your work here?
See, the reconstruction is attempting to recreate it the way the artist originally did, not what nature and the environment did for 400 years. So thankfully, I haven't had to try to do any artificial crackle. That would be going more towards the notion of a copy, or not even a copy,
right.
A forgery.
One of probably the best, something that I was really happy to see, you saw the image at the very beginning with the children in the National Gallery looking at the Giotto. right away, they point out and they ask, why is the Giotto on the wall so yellow? I mean, it's really obvious to see, you know, how these paintings might have looked right off the easel, so to speak. And, you know, it locks into their memory what age can do to these materials, and also coatings, lots and lots of coatings.
I addressed that, and I didn't. The reason that is so brown and yellow brown is that it has a lot of restoration varnish layers on it, and it hasn't been restored or conserved for a very long period of time. When and if the National Gallery decides to conserve that piece, much of that blue will come back, because that's a dirty kind of natural resin coating that's been applied on top of there, and it's degraded over time. I think we need to move into the show and tell phase. Thank you so much.